So as we move on to part C, train is traveling at 250 kilometers per hour. That's where we get our kilometers per hour right here. But keep in mind, we have two things going on here. We have units in the numerator as well as units in the denominator. So the first thing we're going to do is get that numerator unit changed from kilometer to meter. That's what we're doing in this first step that is written in black. Now, to move on, we're going to get the hours. There we go. We're going to get the hours changed to seconds, and we're going to do that by canceling the hours here with the hours here, and then converting hours to minutes with this conversion factor, and then converting minutes to seconds with this conversion factor. So you'll see by the time we get to the end of our problem here, we have converted kilometers into meters. The meters haven't canceled out. We've converted hours into minutes. Everything else here is canceled out. Our final unit on the bottom is in seconds. So meters on the top, seconds on the bottom. We have 0.69 meters per second. For right now, we're going to skip through problem 6. Problem 7, I think I want to talk about problem 7. We're looking here at the idea of precision and significant figures. And the idea here that at the tip of this nail, we can make an estimate to this measurement. It looks to me to be just a little less than 4.4. I'm saying 4.38. And I am supposed to be able to make an estimate to 1/10 the distance between these two lines. And I'm calling it closer to the 0.4. So 4.38 looks like a good measurement to me. You might estimate that last digit slightly different, and that would be okay. Maybe you'd call it 4.39 or 4.37 or even 4.36. On this instrument, however, we only can make an estimate to the closest 1/10 the distance between these two numbers. And I made my guess at about 4.3. It looks to me to be a little less than 4.4 and a little more than 4.2, but once again, that is an estimate. Put these numbers into your calculator and see if you can get the correct answer. If you cannot, you need to get some help on how to operate your specific calculator. Do that for both of these problems so that somebody can help you out if you're not getting the right answer. Here is a graphic organizer of the terms dealing with matter in this unit. And of course, I think it's pretty self-explanatory that all matter, it can be divided into pure substances or mixtures. Pure substances include elements like oxygen and compounds like water. Mixtures, on the other hand, there are two basic kinds of mixtures. Those that have the same consistency throughout, the homogeneous mixtures, and mixtures that are heterogeneous, concrete, chocolate chip cookies, mayonnaise, things that don't let, or milk, that don't let light pass through. If you look at milk with a microscope, you're going to see little globs of fat and all kinds of cool stuff. Not homogeneous. Homogeneous mixtures are things like, well, we refer to them as solutions, and a common one would be salt water. And so we did talk about this chemical and physical changes. So hopefully you recognize here that in the chemical changes that are written, something decomposing or falling apart and changing so that it releases carbon dioxide gas, or something that reacts with an acid, those kinds of things would be chemical properties. And the things that are listed up above here that are physical properties are things like the color and the density or mass to volume ratio. Now the symbols, of course, that's easy. Sodium, hydrogen, carbon, and oxygen. And how did we know that? Well, we read it right up here. Let's see, where is it? Sodium, hydrogen, carbon, and oxygen. And the NFPA symbol, we got the numbers from right here in the problem, and the standardization of these numbers vary slightly. Okay, the top number is always in red, and that's the fire symbol. The left number in blue, and that's the health rating. The right-hand number, always in yellow, is the instability or stability rating. And the bottom one is the one that varies from time to time. The bottom one, sometimes it's a special code. In this particular case, it's the contact rating. So there you go. Good luck on the test. Oh, there's more. Ha ha, just kidding. So watch the video on scientific notation if you have questions about how to make these conversions with scientific notation. And don't forget that on the end of this review sheet, we tacked on a percent error problem. So you should expect to see some kind of percent error problem on the test. So here we have a problem. Calculate the percent error that a chemistry student who measures the length of a block of wood as 13.45 centimeters when its actual accepted length is 15. And so that should come out to the absolute value of what they measured minus the accepted divided by the accepted times 100%. When you put that into your calculator, you should get 10.33%.